will start aldehydic and ketonic groups, which is the fourth part. And first of all, we will do the theory that both the aldehydes and ketones they contain carbonyl group C double bond O, and they are commonly known as carbonyl compounds. Identification of aldehydes and ketones is done by two important reactions of carbonyl group, that is the first one being the addition reaction on double bond of carbonyl group, and the second one is the oxidation of this carbonyl compound. So the addition reaction of the derivatives of ammonia are important from the point of view of identification of carbonyl compound. Addition is generally followed by an elimination resulting in the formation of an unsaturated compound. So these reactions are catalyzed by an acid or a base and do not occur under strongly acidic or basic conditions. Each reaction requires an optimum pH for its occurrence. Therefore, maintenance of pH is very important while carrying out these reactions. As far as oxidation is concerned, aldehydes are easily oxidized to carboxylic acid, while ketones they require relatively stronger oxidizing agents. Distinction can be made between these two groups of carbonyl compounds on the basis of difference in their reactivity. Following tests are performed for the identification of aldehydic and ketonic group. The first one is on reaction with 2,4-dinitrophenylhydrazine, that is 2,4-DNP, they form respective 2,4-dinitrophenylhydrazones. These two carbonyl compounds, aldehyde and ketones, are distinguished on the basis of tests using mild oxidizing reagents like Tollens reagent and Fehling reagent or Benedict's reagent. Tollens reagent is an alkaline solution of silver cation complex with ammonia, and Fehling's and Benedict's reagent are alkaline solutions containing cupric ions complex with tartarate and citric ions respectively. Fehling's reagent is freshly prepared by mixing equal amounts of Fehling solutions A and Fehling solution B. Fehling reagent is deteriorates on keeping, while Fehling solutions A and B are quite stable. Fehling solution A is an alkaline solution of sodium potassium tartarate, which is also known as Rochelle salt. The reagent contains Cu+2 ions which are complex with tartarate ions. The structure of the complex is given below. This is the copper tartarate complex. Benedict modified the original Fehling's test by using a single solution, which is more convenient for the test. Benedict's solution is more stable than the Fehling's reagent and can be stored for a long time. It is an alkaline solution which is containing a mixture of copper sulfate and sodium, and its molecular formula is 2Na C6H5O7.11H2O. The complex formation decreases the cupric ion concentration below that necessary for precipitation of cupric hydroxide. These two reagents they oxidize aldehydes while ketones remain unaffected. So the chemistry of these tests is as follows: that from Tollens reagent we can reduce it to carboxylic acids, and from Fehling reagent also we can form the acetate salt. So however, aromatic aldehydes they do not give positive Fehling's test. In Benedict test also, copper ions are reduced to Cu+2 ions are reduced to Cu plus ions in the same manner as in the case of Fehling's reagent. So aldehydes also give pink color with the Schiff's reagent, that is the reagent is prepared by decolorizing aqueous solution of P rose aniline hydrochloride dye by adding sodium sulfite or by passing SO2 gas, and ketones they do not respond to this test. So let us see what is the material required for us to perform this experiment. You have to take a beaker of 250 ml. You need a test tube holder. You need test tubes. Schiff's reagent you need as per your need. Fehling solution A and B. Silver nitrate, dilute ammonium hydroxide solution, 2,4-dinitrophenylhydrazine reagent. Everything is needed as per the need. So what is the procedure? The first thing being, The test given by both aldehydes and ketones. So first of all, whatever the thing you are being given, you have to identify whether it belongs to the category of aldehydes and ketones. So 2,4-dinitrophenylhydrazine test, 2,4-DNP test. Take 2-3 drops of the liquid compound in a test tube or in a case of solid compound and dissolve a few drops, a few crystals of it in 2-3 ml alcohol. Add a few drops of an alcoholic solutions of 2,4-dinitrophenylhydrazine. Now, appearance of yellow-orange or orange-red precipitate confirms the presence of a carbonyl group. If precipitate does not appear at room temperature, then warm the mixture in a water bath for a few minutes and cool it. Now, the tests which are given by aldehydes only. Following tests, namely Schiff's test, Felling's test, and tolerance test, they are given by aldehydes only. Schiff's test. Take 3-4 drops of liquid compound or dissolve a few crystals of organic compound in alcohol and add 2-3 drops of Schiff's reagent. Appearance of pink color indicates the presence of an aldehyde. Felling's test. Take nearly 1 ml of Felling solution A and 1 ml of Felling solution B in a clean dry test tube. To this add 2-3 drops of liquid compound or about 2 ml of the solution of the solid compound in water or alcohol. Heat the content of the test tube for about 2 minutes in the water bath. The formation of brick red precipitate of copper 1 oxide indicates the presence of an aldehyde. This test is not given by aromatic aldehydes. Benedict's test. Add 5 drops of liquid compound or the solution of the solid organic compound in water or alcohol to 2 ml Benedict's reagent and place this test tube in boiling water for 5 minutes. An orange red precipitate indicates the presence of an aldehyde. Tolerance test. Take 1 ml of freshly prepared 2% silver nitrate solution in a test tube and add 1-2 drops of sodium hydroxide solution to it and shake. A dark brown precipitate of silver oxide appears. Now dissolve the precipitate by adding the ammonium hydroxide solution dropwise. To the above solution, add an aqueous or an alcoholic solution of the organic compound. Now heat the reaction mixture of step 2 in a water bath for about 5 minutes. Formation of a layer of silver metal on the inner surface of a test tube which shines like a mirror indicates the presence of an aldehyde. What are the precautions? The first thing is that you are always to use freshly prepared reagents to perform this test. Do not heat the reaction mixture directly on the frame. Use a water bath. After performing the test, destroy the silver mirror by adding dilute nitric acid and drain off the solution with excess of water. Next test is carboxyl group test. So what is the theory? Organic compounds which are containing carboxyl functional groups are called carboxylic acids. The term carboxyl derives its name from the combination of words carbonyl and hydroxyl because carboxylic functional contains both of these groups which are carbonyl as well as hydroxyl. So these acids they turn blue litmus red and react with sodium hydrogen carbonate solution to produce effervescence due to the formation of carbon dioxide, and this is a test that distinguishes carboxylic acids from phenols. So this is a reaction RCOOH plus NaHCO3, that is sodium hydrogen carbonate, gives you RCOONA, a salt, acetate salt along with water and carbon dioxide. These react with alcohols in the acidic medium to produce esters, that is carboxylic acid plus alcohol. In the presence of acidic medium, conc H2SO4 gives you an ester plus H2O. So what is the material required? You need a test tube holder, a glass rod, some test tubes as per your need, blue litmus paper solution, ethyl alcohol and sodium hydrogen carbonate solution. So what is the procedure? Put a drop of the liquid compound or a drop of the solution of the compound with the help of a glass rod on a moist blue litmus paper. If the blue paper of the litmus changes to red, then the presence of either a carboxylic group or a phenolic group is indicated. Now, sodium hydrogen carbonate test. Take 2 ml of saturated aqueous solution of sodium hydrogen carbonate in a clean dry test tube. Add a few drops of liquid compound or a few crystals of the solid compound to it, and evolution of brisk effervescence of CO2 indicates the presence of a carboxyl group. Now, the ester test. Take about 0.1 gram compound in a test tube and add 1 ml ethanol or methanol and 2-3 drops of conc H2SO4. Heat the reaction mixture for 10 to 15 minutes in a hot water bath at about 50 degrees Celsius, and now pour the reaction mixture in a beaker containing aqueous sodium carbonate solution to neutralize excess sulfuric acid and excess carboxylic acid. Sweet smell of the substance formed indicates the presence of a carboxyl functional group in the compound. Now, what are the precautions? Add the compound in sodium hydrogen carbonate solution slowly so that the effervescence is visible clearly. Next is amino group. Organic compounds which are containing amino group are basic in nature, thus they easily react with acids to form salts which are soluble in water. Both type of amines, aliphatic and aromatic, they are classified into three classes, namely primary, secondary and tertiary, depending upon the number of hydrogen atoms attached to the nitrogen atom. Primary amine has 2 hydrogen atoms, secondary has 1, while tertiary amine has no hydrogen atom attached to the nitrogen. So first is carbylamine test. Aliphatic as well as aromatic primary amines, both of them give carbylamine test, in which an amine is heated with chloroform in a basic medium to give carbylamine RNC, where R is the group alkyl or aryl group, N is the nitrogen and C is the carbon with KCl and water. Caution: carbylamine so formed is highly toxic and it should be destroyed immediately after the test. For this, cool the test tube and add carefully an excess of conc HCl. Azodide test. So aromatic primary amines, they can be confirmed with azodide test. Primary amine, for example aniline, it reacts with the nitrous acid generated in situ by the reaction of sodium nitrite with HCl at 0 to 5 degrees Celsius to produce the diazonium salt. This couples with beta-naphthol to give a scarlet red dye which is sparingly soluble in water. This one is the reaction in which we have a primary amine. Basically, we are having the aniline and we are reacting it with nitrous acid NaNO2, which is generated in situ by the reaction of sodium nitrite and HCl. Okay, so this couples with beta-naphthol to give a scarlet red dye. This is the benzene diazonium chloride. This is a salt, and when it is reacted with beta-naphthol, it gives a scarlet red dye which is sparingly soluble in water. So basically the material required is one test tube holder, a Bunsen burner, we need some test tubes, we need chloroform, we need potassium hydroxide KOH, sodium nitrite solution NaNO2, and aniline, beta-naphthol, dilute hydrochloric acid, sodium hydroxide solution and ice. So, solubility test. Take 1 ml of a given organic compound in a test tube and add a few drops of dilute HCl to it. Now, shake the contents of the test tube well. If the organic compound dissolves in it, this shows the presence of an amine. For example, when we add HCl to aniline, remember dilute HCl, it gives anilinium chloride which is soluble in water. Second one is carbylamine test, which is you have to take 2-3 drops of the compound in a test tube and add 2-3 drops of chloroform, which is followed by addition of an equal volume of 0.5 molar alcoholic potassium hydroxide KOH solution. So now you have to heat the contents gently, and obnoxious smell of carbylamine confirms the presence of primary amino groups in the compound. So now do not inhale the vapors, destroy the product immediately by adding conc HCl and flush it into the sink. Second one is azodide test, that is you have to dissolve nearly 0.2 grams of the compound in 2 ml of dilute hydrochloric acid in a test tube, and you have to cool the content of the test tube in the ice. So to the ice cooled solution, add 2 ml of 2.5% cold aqueous sodium nitrite NaNO2. In another test tube, dissolve 0.2 gram of beta-naphthol in dilute sodium hydroxide solution. Add diazonium chloride solution, which is prepared in step 2 into cold beta-naphthol solution slowly with shaking. Okay, so the formation of a scarlet red dye confirms the presence of an aromatic primary amine. Now, what are the precautions? Do not expose yourself to the vapors while performing the carbylamine test, because isocyanide is highly poisonous. Destroy it immediately as described above. Maintain the temperature of the reaction mixture below 5 degrees Celsius during diazotization, as diazonium chloride is unstable at higher temperatures. Okay, always add diazonium chloride solution into the alkaline solution of beta naphthol and not vice versa. Okay, you don't have to add the beta naphthol solution into the diazonium chloride solution. You have to add the diazonium chloride solution into the alkyne solution of beta naphthol. So, discussion questions. This is a set of questions asked from all over the set, because first of all, we did about in the starting of this chapter. I have completed this whole chapter in 3 videos. In the first one, we did the test for unsaturation, and it contained basically our 2 experiments. The first one being the bromine water test. It was covered over in the first video. Bayes test was covered over there. Okay, then the test for alcohol came. We did the steric ammonium nitrate test, which is the easiest of all. Then the iodoform test, and then the Lucas test. These 3 tests were performed for alcohols. Then we came for the phenol. In the phenol, there were the first test was ferric chloride test. This was very simple. Second was phthalate dye test. And now we came to aldehyde and ketonic groups. In this video, we started this. Okay, so we have the first thing here, the test given, which is given by both of them. Then we studied those tests which are given by aldehydes only, and in those also the Schiff's test. Okay, the first one being the Schiff test, it gives us the presence of an aldehyde, means both aliphatic and aromatic, both of them shows this. Okay, Schiff's test. Then the Felling test, it is given only by the aliphatic and it is not given by the aromatic aldehydes. And then the Benedict's test, it is given by Benedict test is given, I think it should be given only by the aromatic aldehydes, because their aliphatic was there. Okay, so this was the Benedict's test. Nothing is written over here, but you can find out. Tollens test. Tollens test is a bit different from all, because silver is made, so it is bit easy to remember. Fine. The next is carboxyl group that we studied. In this we had a litmus test, a sodium hydrogen carbonate test, and an ester test, which is usually very liked by the students. Okay, then the amino group, which is basically the first thing is carbylamine test, then the azodide test, and then okay, so solubility test, carbylamine test, and azodide test. These are the 3 tests in the part of COOH, carboxylic acid. So now what is the discussion? The first thing is that these questions gives us some idea about what is important and which topic is not important. So the first question is, what is Bayes region? So this is basically we did it in the first very video. So second is, why do alkenes and alkynes they decolorize bromine water and alkaline KMnO4? Just because the bonds are break, the double bonds are break, and bromine is attached with the transposition, right? So explain why for the confirmation of unsaturation in a compound, both the tests, namely the test with bromine water and test with Bayer regions, should be performed. It's just like to confirm, right? So why does phenol decolorize bromine water? How will you distinguish between phenol and benzoic acid? It is given here. Why does benzene not decolorize bromine water although it is highly unsaturated? See, ask this from your teacher. This is a good question. I think that benzene is aromatic and it does not want to lose its aromaticity. Is that the reason? So why does formic acid gives a positive test with Tollens reagent? This is also an exceptional case, right? Formic acid. Outline the principles of testing glucose in a sample of urine, a pathological laboratory. Okay. Why is Benedict's region more stable than Felling's region? The answer is given. How would you distinguish an aldehyde from a ketone by chemical test? Easy. How will you separate a mixture of phenol and benzoic acid in the laboratory by using chemical method of separation? This can also be done. Write the chemistry of diazotization and coupling reactions. So how can you distinguish between hexylamine and aniline? Okay. So how can you distinguish between ethylamine and diethylamine? How can this and this be distinguished chemically? Why is the solution of iodine prepared in potassium iodide and not in water? What is haloform reaction? What type of compounds generally this reaction give? What type of compounds generally give this reaction? And how can I distinguish the compounds this and this by simple chemical tests? So it's better if you remember these tests, because these are an important part of your syllabus. Basically for your practicals this constitutes an important part, क्योंकि जो मेजर पोर्शन है रटने वाला वो या तो केटाइंस और एनाइन से आता है या फिर फंक्शनल ग्रुप से आता है. सो आप एक काम करिए, जो भी हमने पढ़े हैं उस मतलब जितने भी एक्सपेरिमेंट्स किए हैं फंक्शनल ग्रुप्स के, हमने बेसिकली 6 कर लिए मेरे हिसाब से. The last one was COOH. 6 या 6 हुए हैं. उसमें से सबसे पहले तो आप सिर्फ और सिर्फ एक कागज़ का टुकड़ा, एक पेज लेना है, उसके आगे और पीछे सीरीज़ में पहले तो आप सीरीज़ वाइज वो लिख लीजिए, क्योंकि 6 एक्सपेरिमेंट है तो आप मान के चलिए एक पेज लेकर उसको 3 हाथ में फोल्ड कर लीजिए. ठीक है. अब आप एक डब्बा एक को देना ही देना है आपने, चाहे ज़्यादा हो सामान चाहे कम हो. हाँ, ये जो टॉलेंस रीजेंट है, जो एल्डिहाइड कीटोन्स वाला पार्ट है, उसमें ये थोड़ा ज़्यादा इंपॉर्टेंट जो मैटर है आपका वो ये वाला है, बेनेडिक्ट, शिफ्ट्स, फेलिंग एंड टॉलेंस. इसको आप ज़्यादा टाइम दे सकते हो. जो चीज़ आपको याद नहीं रहती है उसके शॉर्ट नोट्स बना के अपने पास रखो. इसे टाइम से मतलब हर तीसरे चौथे पाँचवें छठे दिन जब भी आपको टाइम मिले इसे एक बार ही रिवाइज कर लो, बिकॉज आपके जो प्रैक्टिकल्स हैं उसमें एग्जामिनर इज़ योर गॉड. ठीक है. आपने प्रैक्टिस भले ही ना करके देखा हो कोई भी चीज़, बट इफ़ यू नो व्हाट टू डू, किसकी कितनी क्वांटिटी लेनी है, कितनी कॉन्सेंट्रेशन का होना चाहिए. अब कॉन्क HCl की जगह आप डाइल्यूट डाल रहे हो और इंतज़ार कर रहे हो कि रिएक्शन होगी, तो नहीं होगी. यू हैव टू क्रैम करने की ज़रूरत ही कहाँ है यार. सब कुछ समझ आ रहा है, आराम से समझ में आ रहा है. ठीक है. सो आई होप यू लाइक दिस वीडियो, एंड इन दिस वीडियो फाइनली वी हैव कवर्ड दिस चैप्टर यूनिट 8, and I'll be making the next video for cations and anions as soon as I get it. So I hope it helped you, and thank you so much for watching this video.